All right, so let's evaluate some limits involving infinity. So the first thing I want to do, this is the problem that we left off with yesterday. The limit as x approaches 7 for 3 over x minus 7. Notice that if I plug in x equals 7, I get 3 over 7 minus 7, or 3 over 0, which creates a vertical asymptote. Remember, this is not 0 over 0 we're talking about. This is a non-zero divided by 0. Be careful, because if we get a non-zero over a 0, that creates a vertical asymptote. Now, the key to a vertical asymptote is knowing the behavior to the left. Let me just point to it with my pen really quick. Knowing the behavior to the left and to the right of x equals 7, because let's just clear the air. 3 divided by 0 is undefined. You plug it into the to the calculator. 0 times what is 3? It's mathematically impossible. 0 times anything would be 0. Therefore, 0 times something equals 3 is a multiplication problem that's impossible to solve. So it creates a vertical asymptote. Now, I spoiled it earlier, but the limit in here does not exist. Now let's explore why. Because if we take the left-hand limit, in other words, plug in x equals 7, but remember, we're not plugging in 7 as in we want it to be 3 over 0. We're thinking x equals 6.99999999999. We're approaching x equals 7 from the left side. That's what this notation means. Plug in x equals 7, but approach it from the left side. So we've got 3 over basically 6.999999999 minus 7. Now remember, think critically. What is barely under 7 minus 7? Well, it is 0, but it's the left side of 0. 3 over the left side of 0. So think negative 0.00001. So in other words, 3 divided by, a positive divided by a negative is still a negative. So we use that idea combined with the fact that our theory of calculus says that if we have non-zero divided by 0, it is some sort of infinity. So if we get closer and closer and closer to 7 from the left side, 3 divided by 0 from the left side becomes negative infinity. Okay? Now, let's take the right-hand limit. So we're going to approach x equals 7 from the right side now. In other words, 3 over x minus 7, where we plug in x equals 7, but we approach x equals 7 from the right side. So think if x was 7.001. So if x equals 7.001, that means that it's barely above 7. So if I have barely over 7 minus 7, I'm going to get like 0.0000001. So 3 over the positive side of 0. What is a positive divided by a positive? It's a positive. So 3 divided by 0 from the right side would be positive infinity. And just to show that we can do this, if I take the graph of 3 over x minus 7, notice that x equals 7 is illegal. So if I plug in x equals 7, I create this dotted line. If I approach it from the left side, zoom out a little bit. And it may show that it's aligned with it, but think about it. If x gets closer and closer to 7, it wants to go to negative infinity. And I could zoom out even more. I could drag this. See? It's going insane. It's not even reaching x equals 7. And let's approach it from the right side. If I zoom in. Oh, whoops. Let me get that on the blue line. No, let me take away there we go. Take away the red line. So if I approach it, it's not letting me get to x equals 7. It's sending it to positive infinity. So I look at this vertical asymptote. From the left side of 7, it wants to go to negative infinity. And from the right side of 7, it wants to go to positive infinity. Therefore, they don't agree on where they're intending. So the limit as x approaches 7 for this problem does not exist. Okay? See if you can do this problem independently. The limit as x approaches -4. And tell me why your solution is the way it is. Okay, I'm just setting up for the next problem on Desmos. Okay, so let's think critically about this. So, if I were to plug in x equals -4, let me get my black pen really quick. So if I plug in 9 over -4 plus 4, because that's my first move, is to apply direct substitution. -4 plus 4 is 0, therefore I've got 9 over 0. Remember, it's a non-zero divided by 0, therefore x equals -4 is a vertical asymptote. Okay? Now, we're going to explore, so I don't need to write it so much in detail, left-hand limit, right-hand limit. So you get the idea that I need to take the left-hand limit as x approaches -4 of 9 over x plus 4. I'm going to take the left-hand limit. All right, come on. So what that means is I'm going to think x equals, so what's the left side? So remember, be careful, we're in the negative world. What is barely under -4? I like to go with -4.001. So once again, I'm plugging in 9 over -4 from the left side. I know it's a little bit confusing, so that's why I use color. So if I were to go -4 from the left side, that would be -4.001. So that would be, if I were to plug in -4.001 plus 4, that would be around x, that would be around -0.001. But it's not, it's approaching it. So we are getting 0, but are we getting the left side of 0 or the right side of 0? The left side of 0. So 9 over the left side of 0. If 9 over 0 would be infinity, this is 9 over barely negative. So if we've got a positive divided by a negative, that's a negative, and the idea of 9 divided by 0 being infinity means that the left-hand limit of as x approaches -4 is -infinity. So let me apply the right-hand limit. All right, so let's do the limit as x approaches -4, but from the right side. And again, those little notes on the side, that's the way I teach it. But yeah, everything here is proper calculus notation. Okay? I just like to put my brain on paper. So I've got the limit as x approaches -4 of 9 over x plus 4. 9 over x plus 4. Remember, the right side of x equals -4. So think barely bigger than -4. So remember, we're in the negative world. I'm going to think to myself, x equals -3.9999999. So just barely underneath. Let me plug this in. I've got 9 over x plus 4, but I'm going to plug in x equals -4 from the right side. And this is proper calculus notation. I kid you not. So if I were to plug this in, -3.999 plus 4, that's my little tip. 9 over, that's going to be barely positive, so that's 9 over 0 to the from the positive side. So a positive divided by a positive is a positive, and 9 over 0 is infinity. So the left-hand limit, but as x gets closer and closer to -4, from the left side, y approaches negative infinity. But as x gets closer and closer to negative 4 from the right side, y equals positive infinity. So the left-hand limit and the right-hand limit don't agree. So the limit as x, the limit as x approaches negative 4 does not exist. Lindsay Lohan. Okay. And just to show you the graph, I was typing it up. So if I were to show you the blue graph, 9 over x plus 4, you'll notice that if I get closer and closer, it forms a vertical asymptote at x equals negative 4. So if I were to trace it from the left side, the graph wants to go to negative infinity from the left side and positive infinity from the right side. Therefore, the limit does not exist at x equals negative 4 because they can't agree on where the y values want to go to. Okay? So I assure you, not all of them are going to be the limit doesn't exist or the limit does not exist, but I just wanted to warm you guys up. All right, number 3. Let's do this one. The limit as x approaches 8 of negative 2 over x minus 8. This one's a little bit different. All right, I'm just going to type it up so that we can graph it later on. Sorry about that. All right, let's do it. So once again, I'm going to apply it in direct substitution. I'm going to plug it in my head. Negative 2 over 8 minus 8. We get negative 2 over 0. In other words, a vertical asymptote at x equals 8. But we knew that. Now we need to figure out what the left-hand limit and the right-hand limit are. So let's do that. So what I'm going to do is I'm going to plug in the limit as x approaches 8 from the left side of negative 2 over x minus 8. You get the idea. I'm not going to do the side notes anymore, but I'm going to speak about them. So I'm going to plug in negative 2 over x minus 8, where 8 is, we're approaching 8 from the left side. So think 7.999 minus 8. Okay, so the top part is still negative 2. Think to yourself 7.999 minus 8. 7.999 minus 8 is practically 0, but from the left side. So negative 2, so first things first, we've got the left side of 0, so it's a negative divided by a negative. That makes it a positive. And 2 divided by 0 is infinity. So the limit as x approaches 8 from the left side wants to go to positive infinity. Now let's approach x equals 8 from the right side. Let me just get a little head of the curve. There's a dog barking outside. I know you like calculus. I know you like calculus, dog. So I'm going to plug in the intent of 8 from the right side. So think 8 from the right side, 8.0001. Negative 2 over barely bigger than 8 minus 8. Well, barely bigger than 8 minus 8 is to the right side of 0. So let's analyze this problem in 2 steps. A negative divided by a positive is a negative, and 2 over 0 is negative infinity. So if I look at the 2 limits, the limit as x approaches 8 from the left side is positive infinity. The limit as x approaches 8 from the right side goes to negative infinity. And I'm going to show you the graph. Look at that. So as we get closer and closer and closer to x equals 8 from the left side, it wants to go to positive infinity. As we approach x equals 8 from the right side, it goes down to negative infinity. And this dotted line does not get touched. Okay? So therefore, the limit does not exist because the left-hand limit and the right-hand limit cannot agree on where they want to go. Okay. Let's do number 4. The limit as x approaches -5 of -12 over x plus 5. Let me just type that up really quick. Okay, see if you can do this problem independently. Okay, now that I'm done typing it. So let's see. Once again, I'm going to use direct substitution because that's my go-to method. So in your noodle, you've got -12 over -5 plus 5. Well, that means it's -12 over 0. Uh-oh, we've got a vertical asymptote. Well, the vertical asymptote means that we need to approach the limit as x approaches -5 from the left and the right. So let's do that. So I'm going to approach the limit as x approaches -5 from the left side. So I'm going to think to myself, barely smaller than -5. If it helps you to write the little notation to put like think x equals -5.001, then go for it. It helped me actually. So I'm going to plug in the left side of -5. Come on, pen. I'm going to get a different pen. This one's failing on me. So -5 from the left side. That's much better. So now, if I were to do -12 on top, and the left side of -5 plus 5, well, that's going to be barely negative. A negative divided by a negative is a positive, and 12 divided by 0 should be positive infinity. Okay, now I'm going to do the limit as x approaches -5 from the right side of -12 over x plus 5. So now I've got -12. Whoops, I put the plus in the wrong spot, but you get the idea. Sorry about that. Nothing a big old x wouldn't solve. But yeah, I'm going to plug it in right there. So -5 from the right side of x plus 5. So if I plug in just barely bigger than -5, let's go with -4.999999. -4.999999 plus 5 is going to be barely positive, so 0.001. Now let's analyze this graph. -12 divided by the right side of 0. So a negative divided by a positive is a negative, and 12 over 0 is infinity. Therefore, the left-hand limit goes to positive infinity. The right-hand limit goes to negative infinity. Therefore, the limit as x approaches -5 does not exist. Showing the graph really quick. Let me just shift it over to the left. Notice that at x equals -5, they both go to positive infinity from the left and negative infinity from the right. Therefore, the limit does not exist. Okay. 2 more, and then we'll call it a day. So these 2 I want to end with because I want to show you that it's not always the limit does not exist. Limit as x approaches 0 for 1 over x squared. Okay. Once again, we're going to apply the left-hand limit and the right-hand limit. Now pay attention because these are tricky. So the limit, sorry, first things first. We're going to do our thought bubble. 1 over 0 squared is 1 over 0. And I don't like that. That's a vertical asymptote at x equals 0. So let's take the left-hand limit and the right-hand limit. Now remember, parentheses are your best friend. You know what I'm going to do? I'm actually going to start with the right-hand limit just to show you. So if I think to myself, 1 over the right-hand side of 0. So think to yourself 0.000001. 0.000001 squared is going to be really, really, really small. But is that going to be positive or negative? It's still going to be really, really small, but it's still the positive side of 0. So 1 over the positive side of 0 is positive infinity. Okay, now this is what confused me in college. So I'm going to plug in 1 over the left side of 0 getting squared. So think negative 0.001, and then that's going to get squared. Well, remember, think this is a negative inside. If we have a negative getting quantity squared, that means that the end result is going to be positive. So negative 0.001 getting squared is going to be really, really small, but on the positive side. So the limit as x approaches 0 from the left side is 1 over the right side of 0, or also positive infinity. So we take a look at the left-hand limit and the right-hand limit. Does the limit as x approaches 0 actually exist? Yes. So the limit as x approaches 0 of 1 over x squared does exist. It is y equals positive infinity. And if you don't believe me, you can graph it here. So I'm just going to zoom in a little bit. It's 1 over x squared. I was just typing in a hurry to get it up. So it's the same thing. So if I graph this, you'll notice that as x gets closer and closer to 0 from the left side, it explodes up to y equals infinity. Same thing from the right side. In fact, I'm going to zoom up and go up. You notice that blue line is practically the same spot, but there's a little bit of space in between. So you get the idea. It's just going to rocket ship up to positive infinity. So the limit does exist. They both go to the sky. Okay. See if we can do this problem now. The limit as x approaches 0 for negative 2 over x squared. Okay. So let's take direct substitution. Notice I'm not going to be happy. Negative 2 over 0 squared. That's 0 squared is 0. So negative 2 over 0, still, I'm not happy with this vertical asymptote. Now, I'm going to take the left-hand limit and the right-hand limit. Okay. The right-hand limit and the left-hand limit. Okay, so let's start with the right-hand limit. So if I take the right-hand limit, in other words, let's just pretend we're approaching x equals 0 from the right side, so 0.001, positive 0.001. So if I plug it in, negative 2 over the right side of 0, well, even though it's so close to 0, it's practically 0, let's pretend it's positive 0.0001. If I square that, is that going to be positive or negative? Still positive. Positive getting squared is still positive, but it's still negative 2 over 0, but from the right side of 0. Negative divided by positive is a negative, and 2 over 0 is infinity. Therefore, the right-hand limit, the limit as x approaches 0 from the right side of negative 2 over x squared, is negative infinity. It wants to go down. So let's do the left-hand limit now. Remember, think negative 0.0001. So I'm going to plug in the left side of 0. And maybe I'm going to get something the same. I'm going to get them the same. So if I have a negative getting squared, that becomes a positive. And now the left side of 0, so negative 0.001 getting squared, is getting closer to 0, but we're actually squaring a negative. And now negative 2 over positive infinity is, negative 2 over positive side of 0 is negative infinity. And if you don't believe, and now the left-hand limit and the right-hand limit agree that we are going to negative infinity. So the limit as x approaches 0 of negative 2 over x squared is negative infinity. And just to show you, I'm going to graph this. Let me go back down to standard. Okay. Check this graph out for y equals negative 2 over x squared. As we approach x equals 0 from the left side, it goes down to negative infinity. And as we approach x from the right side, it also goes down to negative infinity. Let me just zoom out, zoom out, zoom out, zoom out. And I'm going to go down, 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 down. See, there's a little bit of space. They don't necessarily touch. There's always going to be a little bit of space. Anyway, so that's all I got for today. I hope you guys enjoyed this. Have a good day.